So before we move on to kinetic energy, I just want to go over a review question. So how much work is done to lift a heavy box, has a mass of 6.5 kilograms, 2 meters up in the air? So it's wanting us to calculate work. Do you remember how to calculate work? It is force times displacement. Okay, let's see what we were given. We were given mass right here, and we were given the displacement, but we weren't given force. So my question is, how do we calculate work if we weren't given force? And think about it. What kind of work are you doing? What are you working against when you're lifting something up? You're working against gravity, right? What's keeping it on the floor before you lift it up? Gravity. So really, you need to apply a force that counteracts that force of gravity. So if I figure out what's the force of gravity on the box, then if I exert that exact same force upwards on it, well, then it's going to be lifted up. So there we go. So what we can just do here is calculate the force of gravity. And remember, that is mass times gravitational acceleration, which is a constant. So therefore, we have 6.50 kilograms as our mass, and G, remember, is 9.81 meters per second. It always is, always will be, and that is given to you on your data sheet. So when we calculate that, we get 63.765 newtons, okay? I'm not going to round yet because I don't want to do that until I get to the final answer, because now I want to calculate work, which is force times displacement. And now we have the force. That was 63.765 newtons. And times the displacement, it said 2 meters. So that's what I'm going to put in there. Okay, so 63.765 times 2 is 127.5. And that should be joules. Now let's take a look at what we need for significant digits. So here the 6.50 has 3 of them, this 2.0 has 2. So I should only have 2 significant digits in my final answer. The problem here is it's 127, right? The just number, even without a decimal, is bigger than what we can have. So we need to use scientific notation, okay? So decimal's right there. We need to move it up twice for it to be in between the first 2 numbers. So that's what we're going to do. Okay, so what this is actually going to be is going to be should be 1.2 or 1.3. It's going to be 1.3 because the number after the 2 is larger than 5. And then, of course, that's times 10 to the, how many times did you move the decimal? Moved it twice. And then don't forget your units. And there we go. That is the answer to how much work was done. Okay? So we're going to go into kinetic energy today, and that is really just the energy of motion. If something's moving, it has kinetic energy. And then the faster it moves, the more kinetic energy it has. But kinetic energy is actually also dependent on the mass of something, right? So for example, if I have a big truck and a little car moving at the same speed, the truck still has more kinetic energy because it's heavier, it has more mass, okay? So, one cool thing, heat is actually another form of kinetic energy. A lot of people don't think of it as such because, if something is, if water's boiling, it's not moving around. But think about the fact that the particles are moving way, way faster when something is warming up. And so, therefore, it is still technically kinetic energy, okay? But we're just going to calculate kinetic energy of objects, and that's how we're going to do it right here, is using this equation. That's EK. This little K is put down there because if we don't put subscripts next to the E's, then we're not going to know what kind of energy we're talking about, and it could get very, very difficult. So we always put that little K there. That's equal to 1/2 times M, where M is the mass, in kilograms, you guys. Please, please, please remember to put it in kilograms. Times V squared, where V is, of course, the velocity in meters per second. Okay, so we're going to use this equation, so let's get right on to learning how to use it. So we have a curling rock with a mass of 20 kilograms. Okay, let's write that down. Remember, write it right away as soon as you get it. So right now we know we're working with kinetic energy, but sometimes it's nice to be able to do that, so then it helps you know which equation to use when. So it's sliding down a sheet of ice at a speed of 6 meters per second. So there's my velocity. And we want to figure out the kinetic energy of the curling rock. All right, so remember that kinetic energy is equal to 1/2 times m mass times v squared. Okay, so let's plug in those numbers because we got them all. Okay, so mass 20.0 kilograms. Velocity is 6. And then we're going to square that. Now, please, please, please remember from math class your order of operations. You have to do exponents first, okay? Another note, so many people think that this squared applies to the 20, the m, and the 1/2 as well. No, no, no. It only applies to the velocity, okay? So please only square the velocity. So when I'm calculating this, I'm going to do 1/2 times 20 times whatever 6 squared is, which in this case, 6 squared is 36. By the way, you don't have to do this step. It's just my way of showing you, please only square the 6, okay? But if in your calculator at this step, you want to plug in 0.5 times 20 times 6 squared, you will get the correct answer, okay? But let's do this. I can even do this without a calculator. What's 1/2 times 20? That's 10. 10 times 36. That's 360. Well, there you go. And of course it's energy, so it's joules. Let's make sure we have the correct significant digits. 20.0 has 3, 6.00 has 3. Our answer has 3. Everything's perfect. Okay, there we go. And that is our kinetic energy of this, this curling rock. Okay, let's try a few more because again, practice makes perfect. So we got our baseball with a mass of 160 grams. Anything wrong right there? Do we want mass in grams? Nope. We want it in kilograms. So we need to convert this to kilograms. So we want kilograms, putting those on the top. Don't want grams, putting those on the bottom so that these can cancel out. And then for every 1 kilogram I have, 1,000 grams. Okay, so what does that mean? It's just saying take 160 and divide it by 1,000 and you get 0.160 kilograms. Okay, so there we go. Now we're good. We got our mass and that's going to leave the bat at 40 meters per second. So that's our velocity. And we're going to calculate the kinetic energy. I would encourage you to pause the video right now and try this before I work it out for you. So hopefully you paused, and then I'm just going to do this really quick. Because again, this is pretty much exactly like the last one. It was just trying to trip you up with that grams thing, right? So just make sure that you convert to kilograms. But otherwise, there's no rearranging here. Everything is where it should be, right? So I'm just going to do 1/2 times 0.160 kilograms times 40 meters per second. And I'm going to square that. And if I just type that into my calculator as 0.5 times 0.16 times 40 squared, I get 128 joules. But again, take a look at your significant digits. I have 3 here in the 160, but I only have 2 here in the 40 meters per second. So I'm going to have to change this to scientific notation, taking this, moving it up twice. Oh, we already got this answer before. So we should have 1.3 times 10 to the 2 joules, and that is the answer to 2 significant digits. Okay. Now you guys know that I'm going to have to do it where we're going to have to rearrange this equation. So let's look at how we're going to do that. So we have this cute little puppy dog right here. He's running 1.5 meters per second. So that's his velocity. So again, as soon as you get that information, write it down, okay? He has 12.4 joules of kinetic energy. Okay. So there we go. We want to know what the mass is. Okay, so we know here our equation is like this, EK equals 1/2 mv squared. So you can choose to go right ahead and make a new equation for m here, okay? If you're gonna go on to physics 20, it's gonna be something you're gonna want to learn, a skill for sure, but we can also plug in the numbers and then rearrange from there. So here I have 12.4 joules equals 1/2 times m times my velocity squared, so that's 1.5 squared. Okay, then what am I going to do? Well, I have this 1/2 and I have this 1.5 squared on the right side, so I'm going to actually just like multiply that all together because I can, right? This is a number, so this 1/2 is a number, this 1.5 squared is a number, right? And if I'm just multiplying all these three things together, 1/2 times m times 1.5 squared, I don't have to multiply them in that order, right? Doesn't matter the order. So I'm going to go ahead and multiply the 1/2 times the 1.5 squared. Okay, so 0.5 times 1.5 squared is 1.125. Okay, and then what I have left, I have the mass there, okay? Oh, and I didn't write in the units here, but if you don't want to write in the units while you're doing the rearranging step, I totally get it because you just want to get it down to numbers and units. Just don't forget your units at the end. Okay, how do I get m all by itself now? I'm multiplying it by 1.125, so I should probably divide it by 1.125. Here, we can divide that by 1.125. Okay, so that cancels out there. And then when I solve for m, I get 11, and I'm going to stop there because I only need 2 significant digits, and it's mass, so my units are kilograms. There we go. So that adorable little puppy, oh my goodness, that's making me want to go get a puppy, is 11 kilograms. Okay, so just in case you were wondering if you wanted to rearrange the equation, I'm just going to do that down here really quickly. Okay, so if I have to rearrange this equation for mass, this is how I'm going to do it. If you don't want to know how to do this, you're good with just plugging in the numbers, then you can skip this part. Okay, so first I need to get rid of the 1/2. What's the opposite of multiplying by 1/2? A lot of people say dividing by 1/2, which isn't wrong. The easier thing to do, though, is just to multiply by 2, because 2 times 1/2 is just 1, okay? And then anything I do to one side, I have to do to the other. So what I get here is 2ek equals, and then this 2 times 1/2 is just 1, so I just have 1 mv squared left. So in this case, I was solving for m, so I'm multiplying m by v squared, so I need to do the opposite, which is dividing by v squared. Anything I do to one side, gotta do to the other. Okay, that cancels out, and I am left with m equaling 2 times the kinetic energy divided by the velocity squared. Okay, so that is how you would rearrange for mass with the kinetic energy formula if you want to do that first. Okay, let's do our final example here. So we have a 0.800 kilogram hockey puck. Okay, that looks like mass to me. It's in kilograms. Woohoo, that's what we need. Has a kinetic energy of 389 joules. So EK of 389 joules. We need to calculate the speed of the puck as it hits the glass. So we're looking for speed here. Okay, so again, I need to kind of rearrange this, okay? So I don't care what method you do, if you rearrange first and then plug in the numbers, or if you plug in the numbers first and then rearrange. I know most people like plugging in the numbers first. I don't at all. I hate it. Because of course I'm just a big old math nerd, but I know some people like it. I'm even not putting in units for you guys, even though that just seems like the most wrong thing in the universe for me right now. But I'll do it just for you, just so you can see how to do this. So again, this 1/2 times 0.8, I need to take care of that first before I do anything else. So 0.8 times 1/2 would be 0.4, and then we're multiplying that by v squared. Okay, so now I need to get v squared all by itself, so I'm going to divide by 0.4 because it's the opposite of multiplying. Anything I do to one side, I gotta do to the other. That cancels out. What am I left with? That gives me, I guess ready for this, 972.5. Is it really going that fast? That would be insane. Now keep in mind, please, no, it's not going that fast. It's not going 972.5 meters per second. You guys, that's insanely fast. Remember, this is v squared, so we need to just get v, the speed. I don't want the squared anymore. How do I get rid of the squared? A lot of people forget how to do this, so please pay attention. Remember, the opposite of squaring something is square rooting it. If I take the square root of v squared, I will be left with just v. Okay, that's good. Anything I do to one side, I have to do to the other. So in order to get v from v squared, you have to square root both sides, and then you'll get 31 point, wait, I'm gonna just check how many significant digits I need. So I have 3 there and 3 there, so I need 3 significant digits. So my answer should be 31.2 meters per second. Okay, so that is how you would solve for velocity in that situation. Okay, so please don't forget to square root that. And again, if you'd rather learn how to rearrange the equation right away, I'll do that right now with you guys. And if you don't care about that, you'd rather just do this method where you plug in the numbers first, then you can skip ahead. All right, so if you're going to do this way, we're going to start with the exact same first step. I don't like that 1/2. I want to get rid of it. So instead of dividing by 1/2, which isn't wrong, it's just annoying, I'm going to multiply by 2. But anything I do to one side, I got to do to the other. And then 2 times 1/2 is just 1, so that essentially cancels out. Okay, so what do I get? I get 2ek is equal to mv squared. Okay, and again, I'm trying to solve for velocity. So first, I'm multiplying velocity by m, so I'm going to divide by m because that's opposite. I got to do it to both sides. So we get 2ek divided by m is equal to v squared, but not velocity. So what do I have to do to both sides just to get velocity? We just talked about it. You got to square root, right? Okay, there we go. We did that. And so my equation for velocity is 2ek divided by m, that's a k by the way, all square rooted. And that is the equation for that. Okay, if you just want to do that, and then you can just plug in kinetic energy, mass, and then figure that out right away if you just want to plug in the numbers at that step. Okay. All right, you guys, that is it for me today. Can you believe it? I didn't even talk for that long today, but that's what kinetic energy is, and that's how you calculate it. So good luck with all those practice questions.